Welcome to the Explainer. Today, we're trying something kind of different. We've got our hands on a folder of source files, right? From some unknown project. So we're going to be like digital archaeologists, sifting through the clues to figure out what this thing is, to deconstruct a world that's just waiting to be built.
So that's really the big question here. It really feels like we've stumbled upon the blueprints for some kind of complex digital world. Our job now? It's to dig through all these cryptic files, start piecing them together, and see just what kind of machine is waiting for someone to flip the switch. Okay, so first things first. In any kind of investigation, you've got to survey the scene, right? And for us, that means just taking a big picture look at the files themselves, just to get our bearings. And right away, our first clue is just the scale of this thing. We're looking at 32 different files. That tells you immediately this isn't just some simple little script. No way. This is a big, multi-part system with a whole lot of moving pieces. And as we start sifting through these files, a few names just jump right out. And these aren't random, right? They're basically giving us the vocabulary we need for this investigation. We're seeing things like blockchain, miner, wallets, and smart contracts. I mean, these are the pillars of the world we're trying to put together.
All right, so let's start with the data. The files that end in .db. You can think of these as the system's digital vaults. It's where all its memories, all its records are locked away.
So one of those files is called blockchain.db. Now, before we actually peek inside, let's just ask, what is a blockchain? Well, at its very core, it's basically a digital record book. But here's the kicker. Unlike a regular notebook, this one is built with these incredible digital locks and chains that make it almost impossible to change anything once it's been written down. And this is how that chain part actually works. See, every single block has its own unique digital fingerprint. That's the hash. But look closer. See the previous hash? That's the secret sauce. Every block is cryptographically handcuffed to the one that came before it. This creates a chain where if you tried to mess with just one link, you'd basically set off alarms up and down the entire thing. That's where all the security comes from. And what's inside these blocks? Transactions. And this right here, this is the fundamental heartbeat of pretty much any economy. Who paid who and how much? You've got a sender, a recipient, and an amount. And it's all carved in digital stone, permanently. So, we run a little query on this database. And what do we find? This isn't just an empty blueprint. No, there are 217 blocks that have already been created. This thing has been running, building up its own history, one block after another.
Okay, but data, it's just static, right? It's just information sitting there. What actually makes this whole system tick? To figure that out, we need to look at the Python scripts. This is the code that breathes life into this digital world.
Whoa, okay, now this is interesting. Buried deep in the comments of the code, we find a message from a developer, and it's in Portuguese. It's a warning. It says using this particular function, exec, is insecure for production, and it should only be used for testing. This is like a note someone left for themselves, not meant for us to see. It's a little reminder that this whole system, as cool as it is still a work in progress, with some very real security risks.
So what does that tell us? This system doesn't just store data, it acts on it. That warning was all about running smart contracts. And what are those? Well, they're basically automated programs. They live on the blockchain itself, and they just do things. They enforce rules, they move funds, all on their own. No human operator needed.
And one of the Python files lays out exactly how it works. It's a simple, elegant process. The system finds a contract that's waiting to be executed, it runs the code, it updates the status to completed, and then, and this is the important part, it pays a reward to whoever ran it. It's a completely self-sustaining, automated loop. Pretty cool.
Now here's where another part of the story starts to unfold. As you look closer at the file names, you don't just see one version of a file. You see V1, V2, V3. This project isn't static. It's alive. It's evolving.
And if we look at that contract executor again, you can see this evolution crystal clear. Check it out. From version 1 to version 2, the file size and the number of lines of code just explodes. But it's not just getting bloated. When you dig into the code itself, you see they've added new cryptography tools.
So we didn't just get bigger, it got a lot more secure.
And this growth isn't a one-off thing. The mining core, that's the engine that actually builds new blocks. It almost tripled in size from version 1 to version 3. I mean, that kind of explosion in size and complexity tells you that the system's capabilities were growing incredibly fast. Okay, so we've looked at the data, we've looked at the code, we've even tracked how it's evolved over time. Let's take a step back now, zoom out, and put all these pieces together to really see the big picture. What have we actually found here?
You see, this isn't just some random pile of files. Not at all. What we've actually uncovered are the 4 key pillars of a complete, self-contained digital ecosystem. You've got the ledger, which is the history book, the engine, which does all the work, the rules, which automate everything, and finally, the participants, who use and interact with the whole system.
And this all leads us to the real core insight of this whole investigation. We've just deconstructed what's known as a modular blockchain. The best way to think about it is like, a component stereo system versus one of those old all-in-one boomboxes. The data, the rules, the actions, they're all handled by separate but interlocking parts. And that design, that modularity, is what allows it to be so incredibly complex and powerful, but also makes it possible to upgrade piece by piece, or, in our case, to take it apart and actually understand it. So we've seen the blueprints. We've analyzed the architecture of this entire digital world. And that leaves us with just one last, kind of provocative question to think about. We've seen how it was built, but what's going to happen when it finally goes live?